So let us now solve problems involving determining the total hydrostatic force on plate surfaces and also determining its location. So let's start with the first problem. We have a vertical rectangular gate 1.5 meters wide and 3 meters high is submerged in water with its top edge 2 meters below the water surface. Find the total hydrostatic force acting on one side of the gate and its location from the bottom. So what we're asked here is the total hydrostatic force F acting on the gate and also the location of the total hydrostatic force from the bottom of the gate. So let us draw the figure. So we have the free liquid surface, then the gate is 2 meters below the liquid surface, then the dimension of the gate is 3 meters high and 1.5 meters wide. The location of the center of gravity is at the midpoint of this rectangular gate, and below the center of gravity is we have the center of pressure. So the location of the center of gravity is h bar with respect to the liquid surface. Then the center of pressure is below the center of gravity, which is, so the distance between the center of gravity and center of pressure is the eccentricity. So by adding h bar and the eccentricity, the result will be h sub p. And the location of the total hydrostatic force from the bottom of the gate is represented as Z, which is equals to 5 minus HP. So let us now solve the problem. So for the total hydrostatic force, so we have the formula. Total hydrostatic force is equals to the product of the specific weight of the fluid, then h bar, which is the location of the center of gravity, times the area. So the specific weight of the liquid is, since we have water, so we have 9.81 kilonewtons per cubic meter. Then for the centroid of this plane surface, we have 1.5 meters plus 2 meters. So, then the area of the rectangular gate is 3 meters by 1.5. So we have 1.5 times 3. So the result will be the total hydrostatic force acting on one side of the gate is equals to 154.51 kilonewtons. So next is for the location of from the bottom of the gate. So we need first to solve for the location of the center of pressure. So the location of the center of pressure is equals to the centroid of the vertical gate, rectangular gate, plus the moment of inertia at the centroidal axis over the area of the gate times the centroid. And take note, for rectangular area, the moment of inertia on each centroidal axis is equals to bh cubed over 12. So let's now substitute all the given. So h bar will be 1.5 plus 2, which is 3.5 meters, plus the base is 1.5, then the height is 3 meters, so raised to 3, over 12 times the area, which is 1.5 times 3, times the centroid, which is 3.5. So the result will be the location of the center of pressure relative to the liquid surface is 3.7143. And for the location of the total hydrostatic force with respect to the bottom of the gate, we have Z is equals to 5 minus HP. And we substitute HP, so the equation will be Z is equals to 5 minus 3.7143. So the location of the total hydrostatic force from the bottom of the gate is 1.2857 meters. For our next problem, we have a vertical triangular gate with top base horizontal is 1.5 meters wide and 3 meters high. It is submerged in oil having specific gravity of 0.82 with its top base submerged to a depth of 2 meters. Determine the magnitude and location of the total hydrostatic pressure acting on one side of the gate. So what we have here is we need to solve for the total hydrostatic force F and the location of the total hydrostatic force. So the first thing to do is we need to draw the figure. So starting from the free liquid surface, so the vertical triangular gate is 2 meters below the free liquid surface. Then the dimension of the triangular base is 3 meters high and 1.5 meters wide. Then the center of gravity is 1/3 times the height of the triangular gate. Then below the center of gravity is we have the center of pressure. Then the center of gravity, since we have the location of the center of gravity is 1/3 times the height of the triangular gate, so 1/3 times 3 is 1 meter. Then we have the location of the centroid of this triangular gate relative to the free liquid surface is we have h bar. Then the distance between the center of gravity and the center of pressure is the eccentricity. So let's now solve for the unknowns. So starting from the total hydrostatic force F, so the formula for the total hydrostatic force is equals to the specific weight of the fluid times the location of the centroid h bar times the area of the triangle or the area of the plane surface. So since we have the fluid is oil, so we need to multiply the specific weight of water by the specific gravity of the oil, which is 0.82. Then the h bar will be 2 meters plus 1 meter. So we have 2 plus 1. Then the area of the triangle is 1/2 times its base, which is 1.5 meters, times its height, 3 meters. So the result will be the total hydrostatic force is equivalent to 54.3 kilonewtons. So next is the location of the total hydrostatic force, HP. So the location of the total hydrostatic force is just the sum of the location of the centroid plus the eccentricity, which is we have h bar plus the eccentricity I bar over a h bar. So for triangular plane area, so we have to use the formula for the moment of inertia, which is bh cubed over 36. So let's now substitute all the given. So h bar is 3 meters plus I bar, which is bh cubed, so base is 1.5, height is 3 raised to 3 over 36 times the area, which is 1/2 times 1.5 meters times 3 times h bar, which is 3 meters. So the result will be the location of the total hydrostatic force relative to the free liquid surface is 3.167 meters. our last problem, we have the figure below shows a vertical circular gate in a 3 meters diameter tunnel with water on one side and air on the other side. Calculate the horizontal reaction at the hinge. B is how far from the invert of the tunnel is the hydrostatic force acting on the gate. Then C, where will be the hinge support be located, measured from the invert to hold the gate in position. So to start off, so let's draw, we have this figure, then let's identify all the given. So starting from the center of gravity of the circular gate, which is located at its midpoint or at its center. So the center of gravity will be, so measured from the free liquid surface, we have 10.5 meters. We have 12 meters minus the radius of the circular gate, which is 1.5. 12 minus 1.5 is 10.5 meters. So the diameter of the tunnel is 3 meters, and the air pressure on the right side of the tunnel is 45 kilopascal. So what we're asked here, we have the location of the center of pressure, which is HP. Then let's identify also the forces involved. We have the total hydrostatic force F. Then we have also the force due to air pressure. Then the horizontal reaction at the hinge. So what we're asked here is the magnitude of the horizontal reaction acting on the hinge. Next is the location of the total hydrostatic force relative to the invert or at the bottom of the tunnel. And C is the location of the hinge, Z, measured from the invert. So to solve this problem, we can actually solve now for the forces involved. Starting from the total hydrostatic force exerted by the fluid on the gate. So we have the formula, the specific weight of the fluid times the hydrostatic force, the centroid, and the area. So the specific weight is water. So we have 9.81 kilonewton per cubic meter times h bar, which is 10.5 meters. Then the area is the area of the circle, which is pi over 4 times the diameter squared, which is 3 raised to 2. So the total hydrostatic force acting on the gate is 728.1 kilonewtons. So next is the force due to air pressure. So since air occupies all the spaces on this tunnel, so the pressure distribution on the right side due to air pressure is uniformly distributed. That's why the location of the force exerted by the air pressure is acting at its midpoint. So, and also, we can just apply the formula for unit pressure. So, for the force due to air pressure, we have the product of the air pressure times the area of the circle. So we have the air pressure is 45 kilonewtons per square meter times the area of the circular gate, which is pi over 4 times 3 squared. So the result will be the force due to air pressure is 318.1 kilonewtons. And to determine the horizontal reaction at the hinge, we can just apply equilibrium equations. So we have summation of forces along the x-axis equals to 0. So we assume positive going to the right. So the force F is equals to the force due to air pressure plus the horizontal reaction. So the force is 728.1 kilonewtons equals to the force due to air pressure, which is 318.1, plus the horizontal reaction at the hinge, RH. So solving for RH, we obtain 410 kilonewtons. So for the next unknown, so for the location of the total hydrostatic force measured from the invert, so we have, so for letter B, we have for the distance of the total hydrostatic force from the invert x, so we simply get the difference between the total depth of the water, which is 12 meters, minus HP, or the location of the center of pressure measured from the free liquid surface. So for HP, so we have the sum of the location of the centroid plus the eccentricity, I bar over AH bar. So the moment of inertia for circular gate is, we have pi d raised to 4 over 64. So the centroid, or the location of the centroid, is 10.5 plus I bar, which is pi d raised to 4 is 3 raised to 4, then over 64, times the area of the circle, pi over 4 times 3 squared, times h bar, which is 10.5 meters. So the result is 10.554 meters. So therefore, the location of the total hydrostatic force measured from the invert is 12 minus 10.554, which is 1.446 meters. And last, for the location of the hinge relative to the invert, so we must apply the equilibrium equation, which is, we take moments at the hinge. So summation of moments at point O is equals to 0. So we assume clockwise positive. So we have the force times the moment arm, which is x minus z, equals to the force due to air pressure, which is force due to air pressure times the moment arm, which is 1.5. So the radius of the tunnel minus z. So the force, or the hydrostatic force, is 728.1 times the x is 1.446 minus z, equals to the force due to air pressure, which is 318.1, times the radius of the circular gate minus z. So the location of the hinge relative to the invert is equivalent to 1.404 meters.